Integrated Math 3, this is your test review for the trigonometry test. So what this is an assignment. It's a 50-point assignment, but more importantly, it goes over all of the problems that are going to be on the test. The only thing that's changed are the numbers. Okay, so what I'd like you to do is go ahead, do this, and then take your test based on the answers that you get here. All the problems are going to be worked the same way, it's just numbers are going to be different. Okay, so let's go ahead and get started. So number one, on a circle, a line is drawn from the origin to a point 12, 5. The angle theta between the line and the x-axis. The angle theta is between the line and the x-axis. Find the cosine of theta. All right, so if we draw a circle. And these are both positive numbers, so it's going to be over here in the first quadrant, and it's going to look like this. So this is not a unit circle. So the coordinates of this are 12 and 5, and if you use the Pythagorean Theorem, you can figure out the hypotenuse. So it's 5 squared plus 12 squared equals c squared, or let's just call it what it is, the hypotenuse. But it is a squared plus b squared equals c squared, so that equals the hypotenuse squared. Add those together, you get 169 equals hypotenuse squared, and that means the hypotenuse, take the square root of both sides, and the hypotenuse equals 13. So this is 13. Alright, so it's asking you for the cosine. So the cosine, remember the sides are, this is the adjacent, this side is the opposite, and this is the hypotenuse. So cosine equals adjacent over hypotenuse, which for this particular triangle is 12 over 13. And that's your answer. There's no need to go to your calculator and divide 12 by 13, okay? So the cosine of this angle theta, which is what we were looking for, is 12 over 13. That's your final answer, the adjacent 12 over the hypotenuse. All right, pizza question here. A slice of a round pizza has a radius of 8 inches and covers an angle of 45 degrees. What is the length of the crust on the arc of the pizza? So they want to know this value right here, this A right here. Okay, so we're given a formula. Well, we have what we know is the angle here, and we know the radius. This is a radius. If you imagine that's a full circle, that's the radius of the circle. So we have a formula on your sheet, is the S, that's the arc. What they're asking for is the radius times theta. Okay, so we'll write that formula down. Okay, so we have the radius. That's theta, the angle, but it has to be in radians. So we have to come over here and look at 45 degrees, and we see 45 degrees is pi over 4 radians, or you can do it that way, or you can actually do the conversion. The conversion to radians from degrees is degrees times pi over 180. So I'll do that over on this side. Okay, and if you cancel this, this becomes 1 and this becomes 4. 45 goes into 184 times, so it's pi over 4. Okay, this is pi over 4. Again, you could have gotten that straight off your unit circle sheet. Okay, so we're now just going to do a multiplication. It's 8 inches times pi over 4. And 8 cancels with 4. 8 becomes 2, and 4 becomes 1. It just goes away. So 2 times pi is 2 pi, so S equals 2 pi. Now you may say, isn't 2 pi the distance all the way around a circle? Isn't that what we learned? I mean, it says that right here, but remember, this is a unit circle. It has a radius of 1. This pizza has a radius of 8, so that means that just that little distance right there is 2 pi. All right, so that's your answer right there for that. Okay, we will keep going. A unit circle on a coordinate plane, the angle of 5 pi over 3 radians is also drawn on the unit circle. Using the diagram, determine the value of cosine 5 pi over 3. Alright, well, if we remember what we said is that the first of these two numbers is the cosine, the second is the sine. On a unit circle, cosine, sine. So, all they're saying is it's this one. It's 1/2. Okay, so cosine of that angle, 5 pi over 3, equals the first of those two numbers, which is 1/2. And that's the answer. That's all you have to do. Just recognize which is the cosine and which is the sine. Alright, then we'll keep going. Number 4. If theta is 2 pi over 3, then the value of cosine theta is 1/2. Well, let's confirm that. If we come over here, there's 2 pi over 3 right there, and the first number is the cosine, and it's negative 1/2. So that is correct. They're telling you that, but just confirm that you know what they're talking about. What is another angle theta that has the same value as cosine 2 pi over 3? So they want you to find another angle that has that cosine be negative 1/2, and you can just go around and look for anyone that has the first number equal to that negative 1/2, and you'll find it right here. Right here, that's negative 1/2 in the cosine position. So since they're expressing the answer in radians, you express it in radians. It's 4 pi over 3. You could say 240, but they gave it to you in radians, so express it. So it's 4 pi over 3. So go ahead and just write the answer out completely. Okay, and there's your answer. So these questions aren't all long or difficult, okay? All right. A plane is flying at a height of 7 miles when it begins to descend for landing. The runway is 150 miles away from the nose of the airplane along the diagonal. At what approximate angle does the plane descend? Okay, so what you're going to do is, here's your airplane. Okay, here you go. It's got wings on it. It's flying. Here's the runway over here. So here's the runway right there. We're going to say that's where the runway begins, is right there. Alright, so it says it's flying 7 miles high. So we're going to make a dashed line here to make a triangle. I'm only making it dashed so you don't confuse it with the runway here. And then we're going to make a dashed line like this. And we make a dashed line down here from the airplane to the beginning of the runway. Okay, so there's a triangle. It says the airplane is flying 7 miles high, so this is 7. When it begins to descend, the runway is 150 miles away from the nose of the airplane along the diagonal. So they're saying that this, not this, but this is 150. Okay? At what approximate angle does the airplane descend? Alright, so they want to know this angle that it's descending, actually. Okay, that's the angle it's descending. Alright, so that's theta. So this is the opposite of theta. This is the hypotenuse. And this is the adjacent to theta. So, opposite, the angle is going to be, the opposite of the hypotenuse is the sine. And in that case, that equals 7 over 150. Okay, so sine equals (7 over 150). So if we want to know that angle, we have to take the arc sine, sine of -1. Sine -1, or arc sine, and I should put theta there, of sine theta equals inverse sine, or arc sine, of 7 over 150. Okay, so you're going to go to your calculator, and I'll just write it down here. So this becomes theta. It unwraps the theta out of the sine and makes that theta. And I'm going to come to the calculator, and on this calculator it's going to be second sine, that's arc sine, of 7 divided by 150, and close the parenthesis, and that gives you 2.67, just to the nearest decimal place there, 1 decimal place, so that's 2.7. So theta equals 2.7 degrees. That's this angle right here, and that's your answer. Okay. All right, let's keep going. If cosine theta is greater than 0 and sine theta is less than 0, then theta lies in which quadrant? So let's go ahead and just review our quadrants. So there's a circle. I'm going to break it into 4 pieces there. This is quadrant 1. This is quadrant 2, quadrant 3, and quadrant 4. Okay, so this over here is positive cosine, where the cosine is positive anywhere over here. And that's what they're saying. They're saying that cosine is greater than 0. It means it's positive. They're saying sine is less than 0, so it's negative. And sine is up and down, so that means it's down here. Okay, so this is negative sine. That's where it's less than 0. Okay, so the quadrant where you have both a positive cosine and a negative sine would be quadrant number 4. Okay. That's your answer. Okay. Number 8, which of the following radian measures corresponds to 270? So based on the way that question's worded, it's a multiple choice question, but I'm not presenting it as a multiple choice question on this test. So all you have to do is go find 270. There it is right there. And there's the radian measure, 3 pi over 2. That's it. That's your answer. Okay, what is the period of the function below? So we didn't use the word in class period a lot, but period is the distance. Okay, period is the distance it takes the wave to travel one cycle. All right, in physics it's amount of time, so that's why there's a t there. Okay, so let's remind ourselves what these numbers mean. This is the height of the wave. It's how tall the wave is. This is how far the wave is shifted. In the right and left directions. So I'll just put arrows. How far it's shifted in that direction, right or left. Okay, and this is the period. How many times, what is the length of one cycle? So here we go. Let's do this. We're going to draw this. Okay, and we said that if you start at 0, and over here we have 2 pi, this number tells you how many times the wave does a cycle. Let's remind ourselves what a cycle is. The wave starts here, it goes up, it comes down, and it goes back to exactly that same point. That's one cycle. So it's not just up and down, but it's up, down, all the way down, and back up again. That's one cycle. So we said this is how many times it cycles between 0 and 2 pi. Okay, so that's going to be up and down and up and down. That's 2 cycles, 3 cycles, 4 cycles. So 1, 2, 3, 4. So if this is 2 pi, then one cycle would be 2 pi over 4 or pi over 2 or 90 degrees. Okay. Now that doesn't really answer the question here. All you have to remember is this is the frequency. It's how many times it cycles. The period is equal to 1 over the frequency, which equals 1 over 4, which equals 1 over 4. That's the answer. Okay, if the frequency is 4 cycles in one revolution around the circle, then the period is how long does it take it to make one cycle, and that would be 1/4. So 1/4 plus 1/4 plus 1/4 plus 1/4, and that would be the answer to that. Okay? So just remember, it's the reciprocal of this number is going to be the period. Okay, whatever that number is in the problem on the test, it's going to be 1 over that number. Okay. Okay, here we go. Now, this is a law of sines or cosines problem because none of these angles is 90 degrees. How do we know? Well, it's not just by looking at them, but they should designate. If one of these is 90, they should say that one of them, or put a little box, one of those little square boxes right here to indicate that. Since they didn't do that, you assume that none of them is 90 degrees. Okay, so we're going to use the law of sines and cosines. If you can use the law of sines, it's easier. But if you only have, well, let's see if we can use this. In order to use law of sines, you have to have a particular angle and its corresponding side. So sine A over side A, sine B over sine B, sine C over sine C, over side C. So you notice that they're opposite each other. So here's angle B, here's side B. Here's angle A, here's side A, and here's angle C, here's side C. So the sides are always opposite on the opposite side of the triangle from their corresponding angles. Okay, let's see if we can use the law of sines because it's easier if we can. Well, we need to know here all we're given is sides. We're not given any angles, you can see. Therefore, we cannot use the law of sines because we need to know at least one angle in order to use the law of sines. So we're going to have to use the law of cosines. Okay, so which of these formulas, there's 3 of them, which of these formulas do we use? And the answer is you can use any one of the 3. Because you know side C, you know side A, you know side B, you know side A, you know side B. The only thing you don't know is the cosine of C. So there's your unknown. And all these other 2 formulas do is do the same thing in different order. You can use any one you want. So I'm going to go ahead and I'm going to use this one right here. C squared equals A squared plus B squared. So, and yes, you can use that sheet on the test. Okay, let's plug in the numbers. So C, well, let's go ahead and set them up. So C, here's angle C. So this has to be side C. So that's C equals 6 inches. This is angle A, so this has to be side A. It's on the opposite side of the triangle. And this is angle B, so this has to be side B. All right. Now we'll go ahead and just plug in. So it's 6 inches squared equals 14 inches squared plus 9 inches squared minus 2 times Side A is 14. Side C is 6. Okay, and I did that wrong. It's B. That should have been B. A squared B squared minus 2AB, so let me change that B to 9. Okay, and then it's the unknown is cosine of C. Okay, so let's do that again. C squared is 6 squared, plus 14 squared, that's A squared, right there, plus 9 squared, that's B squared, minus 2 times A, which is 14, times B, which is 9, times cosine C. So let's simplify this. You have 36 equals 196 plus 9 squared is 81 minus, and 2 times 14 is 28, and 28 times 9 is 252 times cosine C. Okay, now we're going to subtract 196. We're trying to solve for this. So 196 minus 81. So over here it's minus 196 minus 81. And these just cancel out. And 36, this gives you negative 241 equals negative 252 times cosine C. I'm going to divide both sides by negative 252. This cancels, and 241 divided by negative 252 equals 0.95. So that means cosine C equals 0.95. Now we're going to take the inverse cosine, because we want to know what C is, of cosine C. And that's simply going to be C. And the inverse cosine of 90.95. And that gives us 18.2. Okay, so that means this angle right here is 18.2. That's angle C that we just figured out. Okay. And now it wants us to figure out the other angles, A and B. But now that we have one of the angles, we know angle C and we know side C, we can use the law of sines, which is easier. Generally, it's less calculations. So let's do that. So we know C, so that's what we're going to start with. Sine of C over C equals, and you can pick to choose either angle, to figure out either angle A or angle B. So we'll go ahead and use angle A. So that's going to be sine of A over the side that's labeled A. So sine C we've got is this. Okay, so we need to solve for this, so we're going to multiply both sides by 14 so that cancels out. You got to multiply this side by 14. So sine A equals all of this. Okay, so what we have is sine A equals all of this, so I'm going to write sine A over on this side. And then I'm going to just multiply sine of 18.2 times 14 divided by 6, and that gives us, and that equals 0.73. Okay, so now I'm going to take the inverse sine of this, rewrite it down here, kind of run a little tight on space, so I'll give you more space for this problem on the test. So it's going to be inverse sine. We're trying to get this out of the I don't need to write that step. So inverse sine of this just makes this A. And inverse sine of this gives you, so you're going to do second sine, second and sine, and then 0.73. And that gives you 46.8. Just call it 49. That means angle A here is 49 degrees. Alright, and then to get B, you simply say 180 minus 49 minus 18.2 is going to equal this angle, because all three of these have to add up to 180. So that's going to give you 112.8. And that's this angle right here, 112.8. So you have all three sides and you have all three angles, okay? So the first one, you got to use law of cosines. After that, you can use law of sines. And then for the final angle, you just use the relationship that all three angles have to add up to 180. So you can just simply do that, okay? All right, let's keep going. All right. Okay, this one looks messy. You're trying to get to theta, so you've got to kind of simplify all this so that you just get to theta. So the first thing you're going to do for this is divide by -6. And this cancels out. And this becomes 3 over 6 is 1/2. So that just means you have a 2 on the bottom. So this is going to be negative square root of 2 over 2. That 3 over -6 just reduced down to a 2, with the negative sign being put out there. Okay, and that equals cosine theta. Now hopefully you've done enough of your homework assignments and problems to recognize that number. That number shows up on your unit circle. Alright, so let's see. There's square root of 2 over 2, but we don't want that. We want negative square root of 2 over 2. So we come around here. There it is right there. And we want it for the cosine, meaning we want it in the first of these two. We wanted the first of these two. So there it is right there. And if you come down here, there it is again. So it's at 135 and 225. Okay, so that means theta equals, but everything on this test is done in radians. So instead of saying 135, you just look at this chart here, and it's 3 pi over 4. And down here, it's 5 pi over 4, this one right here. And that's your answer. Okay, so it's just a little algebra step, then recognizing this number. You don't have to go to your calculator and do that. That's not what they're really looking for you to do. Recognize that you've seen that on the unit circle. Okay? All right, let's do number 12. We're almost done. So, cosine squared theta equals sine theta plus sine squared theta. Now, this uses a principle that I put on your formula sheet, but you were never asked a question on the homework. So let's just go ahead and do it here, and you'll learn it, okay? It's basically this, that sine squared theta plus cosine squared theta equals 1. Why is that? Well, if you come to your unit circle and you look at 30 degrees, for example, and remember on a unit circle, this hypotenuse is 1. So if you take sine squared, that's 1/2 squared, that's 1/4. And if you take cosine squared, that's square root of 3 over 2 squared. The square root of 3 squared is 3. The square root of and 2 squared is 4. So this becomes 3/4. This becomes 1/4. And that equals 1 when you add those together. Sine squared plus cosine squared equals 1, which is this, the hypotenuse. That's what it should equal, because that's actually hypotenuse squared, but 1 squared is simply 1. So that's all you have to, you don't really even have to understand that to do this, but what you have to do is make a substitution. if sine squared theta plus cosine squared theta equals 1, then we have a cosine here. Let's go ahead and change that into a sine. Now we know how to do that. So we'll write that relationship. And now what we're going to do is solve for cosine here. So we're going to subtract sine squared theta from both sides. These cancel, and you end up with cosine squared theta equals 1 minus sine squared theta. Okay, so now that we know that, we can substitute that over here. So where I see cosine squared theta, I'm going to now call that 1 minus sine squared theta. Okay, so that equals that right there, okay, based on what we said over here. Okay, equals sine theta plus, I'm just copying this side a second time, sine squared theta. Okay. Now what we can do is, I'm actually going to change this, guys, to make it an easier problem. I'm going to make that a minus sign right there. Okay, and I'll do that on the test too. So this is a minus sign. I don't want to do one of these quadratic ones. I just don't want to do that on the test. Okay, so now what do you do? Now we're going to simplify. So I change that. And so what we do is we add sine squared theta to both sides. And these cancel. And you end up with sine theta equals 1. So go to your unit circle and find an angle where sine theta equals 1. And remember, the sine is always the second one of these pairs. So there it is right there. Sine of theta equals 1. And that's at pi over 2 or 90 degrees. We call it pi over 2. So theta equals pi over 2. And that is your answer. Okay, and that's the entire test review. Didn't take that long. The test won't take that long. Just learn these principles, and that'll do it. I'll have the test up on Thursday afternoon by 2 o'clock, and we'll go ahead and do this. All right, so we'll see you then.